I hope you are keeping safe. This morning we are going to talk about preparation of base. How can we prepare base in the lab? The first method is combustion of reactive metals in air. Now when electropositive metals, e.g. calcium, copper, nitrogen, good morning everyone, welcome to Smart Mentor Tutor. This morning we'll be talking about preparation of base, and the first one we'll be talking about is combustion of the reactive metal in air. And when electropositive metals such as calcium or copper are heated in oxygen, they form what we call metallic oxide. And a good example is what you have here. Calcium is electropositive metals, and when it is heated in air, it forms calcium oxide. 2. Reaction of metals with steam. Automatically, when you react with metal with steam, what are you going to form? You are going to form calcium hydroxide and hydrogen gas. Please note that when metal is reacted with steam, it produces hydrogen gas. Then the third one is the decomposition of metal hydroxide by heating, just the vice versa. Now when you have metal hydroxide, this calcium hydroxide is heated, it will decompose into calcium oxide and water. Another example is when you have copper hydroxide and it is heated, it will decompose into calcium oxide and water. Another way of preparing base in the lab is the preparation, precipitation, or double decomposition reaction. It's what we call precipitation or double decomposition reaction. When you look at it, this is a double decomposition reaction. When you have copper sulfate and sodium hydroxide reacting together, this Cu2+, then this SO4, 2-. Likewise, when you have sodium plus, then you have OH-. This is a double decomposition reaction. What happens? Copper 2 ion goes to hydroxide ion to form copper hydroxide, while sodium goes to what? Sulfuric, go to what? Sulfate 6 ion to form sodium sulfate. This reaction is what we call double decomposition reaction. Then we can talk about precipitation reaction as well. Then we talk about dissolution of metallic oxides in water. Now when you have sodium hydroxide and you add water to it, what happens? It forms sodium hydroxide. When you have sodium oxide, dissolving it in what? In water, this will form what we call sodium hydroxide aqueous. Likewise, when you have this, you are what? Dissolving it in water, what will form? It will form potassium hydroxide. With this way, you prepare what we call base in the lab. Now let's quickly talk about the reaction of base. The first one is base can react with acid, as we know. This ACL and this was base. By the time you react them together, they form what we call salt and water only. Like the example, turn this one to ions, turn this one to ions, then this one to ions, turn this one to what? Ions. Then what happens? Sodium plus we go and make what? Chloride ion to form sodium chloride. Right? This one too we need this to form water. That is one way of prepare. That is one way of what? Reacting what? Base with what? Acid. Another one is reaction of what? Metallic hydroxide with heat, which we'll discuss about this when we're preparing base. Now, you can heat up this to form zinc what? Oxide and what? H2O. Likewise, when you have copper hydroxide, you can heat it to form copper oxide and what? H2O. Then another one that is very, very important to what? Base is the reaction with what? Ammonium salt. Any salt made from what? Ammonium ion. This is a very good example. And what will happen in the presence of heat? When you heat them, they will produce what we call ammonia gas. That's very, very important. Automatically, when we're talking about base, anything that can react with what? Ammonium salts to produce ammonia gas, that thing is a what? It's a base. And a good example is this. When you have this, you have NH4 plus Cl minus, this plus this Cl minus, Cl minus, then you have calcium 2 plus OH minus form this, while this one will form this. Automatically, this one is forming this, form what? Calcium chloride, while this one is forming what? Ammonium hydroxide, which is what? NH4OH. This ammonium was hydroxide, which by the time you heat this ammonium hydroxide, it will give what we call NH3, this ammonia gas, plus what? H2O. Just like acid that will give CO2, carbon dioxide. When we react with what? When you react acid with carbonates for ions. Therefore, in this particular case now, they must give what we call ammonia gas. This is another way of even testing for a substance which is a what? Is a base. Now, uses sodium hydroxide is a common what? Is the most common base, and it is very soluble in water. Hence, it is used as a what? Drying agent. It is used as a what? Drying agent. Then we talk about using what? Making our soap. If you remember your saponification, we use sodium hydroxide making our soap. Then calcium hydroxide is using what? Neutralization of salt acidity. You need to understand this as well. The soil that contains what? Acid. If you want to neutralize the acid, you add what? Base to it. Aside this one is using what? Toothpaste. You can check the content of your paste. You discover that there is what? Magnesium hydroxide. And we know what magnesium and calcium do for our teeth. The calcium hydroxide is used in making what? Mortar and what? POP, that is plaster what? Paris. Whitewash and cement and what? Sugar refinery. Then talk about ammonium hydroxide is using what? It is using what? As a grease solvent or as a cleaning what? Agent. Likewise, ammonia is used in making what? Fertilizer. When you're talking about fertilizer, you're talking about NPK and detergents and all. Detergents. Then let's talk about we talk about relative acidity or alkalinity. We call it the pH scale. The 10 pH denotes hydrogen ion index. It is a number scale used to express the degree of acidity or alkalinity of a solution. And the number ranges from 0 towards 14, very important. A solution with pH value of less than 7 is acidic, while one greater than 7 is what? Alkaline. And a solution with pH of 7 is what we call what? Neutral. It is neither acidic nor what? Alkaline. The pH of a solution can be measured with a what? With an instrument called pH meter. I'm going to discuss all this for the class. Now look at it. The color, the pH number, and the words, and the acid and base. Yeah, but in this particular case, when we're talking about red, you'll be seeing is between 1 and 3 and the very, very what acidic. When you have orange as an indicator, it's between 4 and 5, and that is a weak acid because it goes from 7 to what? 0. Then yellow is 6. In this case, we begin to see, then when you have indigo, you have it as what? A weak base, which is going from 9 to what? 10, for basicity, it will be increasing from 7 to what? 14. Let me waste time with this. Then you see, these ranges like our battery acid, very red is 0.5. Gastric acid is between 1.5 to 2.0. Our lemon is 2.4. Our vinegar is what? 2.9. Oranges, the acid in our oranges, almost light yellow, is 3.5. Beer, our beer to contain what? Acid. Coffee, then pure water, 7.0. Then everyone was saliva. Our saliva is what? This one now is moving towards this neutral. Then this one is a weak acid. It's between acid and what? Base. Our blood too. Our blood is basically base here. It's not an acid because that jump from 7.0 to 7.3 for seawater. All these, they are what? They are basic in nature. Our anto to our caustic soda, they are very, very basic. And our household here is equally what? They are base. Okay, this is our pH scale. These are pH scales, ranges from 0 to what? 14. And you can see it, the hydrogen ion concentration in the solution. When it is 0, you have it as 10. When it is 1, you have it at 10 is minus 1. When it is 2, you have it at 10 is power minus 2. When it is 3, you have it at 10 is power minus 3. You see the implication of this one, hydrogen ion concentration. With this hydrogen ion concentration, we can use it to determine our pH or pH of that particular solution. Now let's quickly talk about logarithm pH scale, which I've already explained before. Sorensen in 1909 introduced the logarithm pH scale to eliminate what? Inconvenience encountered when using a negative index and to give room for a wide range of hydrogen ion and the OH ion concentration that we do come across in acid-base reactions. It defined pH as the negative logarithm of the hydrogen ion concentration to the base 10. Negative logarithm of the hydrogen ion concentration to the base 10. For example, if the hydrogen ion concentration on an aqueous medium is 10 to the minus 5 mole per dNK, then the acidity of the solution will be written in terms of pH as follows. Look at it. This hydrogen ion concentration has 10 to the minus 5 mole per dNK. Then the log of what? Hydrogen plus will equal to log of 10 to the minus what? And if you do this, you have what? Minus 5, because this will come to the what? To this place. Then log 10 to base 10 will equal to what? 1. And we have it as well log 5. Therefore, the pH of minus log hydrogen plus, the pH is the negative logarithm of the hydrogen ion concentration. As we are saying here, this particular one is what we've gotten as what? Minus 5. By the time you insert your minus 5 to this, you have minus 5, and that will give us what? 5. What is the implication? The implication is very simple. If the hydrogen atom concentration is 10 raised to power minus 5, automatically the pH is going to be equal to what? S. If I have 10 raised to power minus 6 now as my concentration of what? H as my concentration of hydrogen ion in the solution, automatically my pH will equal to what? Simple as that, will equal to 6. It's going to equal to what? 6. And that is the implication. Proportion to each other, when you have the hydrogen ion concentration multiplied by the OH ion concentration, that will give you 10 raised to power what? Minus 14. Because we know that this H plus is 10 raised to power minus 7. Then you have OH minus is 10 raised to power minus 7. Then when you now have both of them together, that was what we are going to get. That will give you what? 10 raised to power minus 7 multiplied by what? 10 raised to power minus 7. And that will give me, when they have the same base, I pick one base. Then the index, what happened when it is multiplication, I had minus what? 7. And that will give me 10 raised to power what? Minus 14. Therefore, the multiplication of both hydrogen ion and the OH minus in the solution will give you 10 raised to power minus 14. And you need to know that pH plus POH will give me what? 14. Which we still remember that when you have 10 raised to power minus in the pH, because basically when you have hydrogen plus will be minus and the pH will be 7. When I have OH minus equals to minus 7, the pH will be what? 7. A high pH value indicates low what? Hydrogen plus concentration, that is weak acidity, while a high OH concentration indicates what? A strong alkalinity. And I've told you about this before. Therefore, calculate the pH of 0.005 mole per dm³ of the terms of a cis acid. The first thing I need to do here is I need to write the ionization equation. Therefore, when you dissociate this, remember this compound is formed by what? Hydrogen plus and SO4 minus. And I have to balance the atom of hydrogen here is 2 here. I have to put 2 here. While this particular one together is what? 1. To remain this one as 1, irrespective of the charge. And what is the implication? Implication is, according to this, 1 molar of this will equivalent to what? 2 molar of this, according to this particular equation. Therefore, we have 0.0 of this. Automatically, if 1 is equivalent to this, then 2 will be equivalent to what? This times 2. That is the meaning. Therefore, the hydrogen plus in this particular equation will be 2 times what we are given. 2 times 0.005. Because in this case, 1 molar is equivalent to what? 0.00. Automatically, 2 molar will equivalent to what? Times 2 of it. And we have it as what? 0.001. This is what we have, 0.001. Then I have to put it in standard form. And when you are moving from what? Right to left, count 1, 2, 3. You count 1, 2. Okay. When you multiply this by 2, what you're supposed to get here, is 0.01. That'll give me more per dm cube. Not 0.001. What you're supposed to get is 0.01 mole per dm cube. Then I have to convert this one to standard form, move from right to left to 1, 2. Therefore, in this case, I'm going to have 1 times 10 raised to power. And when you are moving from right to left, it should be minus 1, 2, minus 2. Therefore, in this particular case, pH equals to what? Minus log H plus. Therefore, the pH equals to minus log, open bracket, 1 times. Now, I've already told you that this one multiplied by this will give me what? 2. Still remember then minus log 1. This one, minus log 1. Minus times 1. Minus log times 1 will give you what? Minus log 1. And that will give me what? 2 is 2 minus 0, and that will give me what? 2. That is the first example that you need to know how to do. Look at this particular second example. The hydrogen ion concentration of the fruit juice is given as this. What are we giving? We are giving hydrogen what? Plus what is the pH of the what juice? Is it acidic or basic? Likewise, the same thing. All we need to do is remember the definition of pH equals to minus log H plus. In this case, we are given what? H plus. What do you need to do? pH equals to insert it. In this case, what you get your answer. In this case, I have to do that when you have this and you have this. When you are using minus log to multiply everything in the back one by one. So I started with this and they will start with this one first. You know, by the time you multiply minus log times x by minus 2, that will give you 2. Now it's 2 minus. Then use this one to now multiply this minus log 3.3. And that will give you what? 2. That will give you 2 minus. Then log 3.3. What is log 3.3? Log 3.3. That is 0. That's giving me 0.52. Then I have 2 minus answer. I will give you what? 1.8. 1.48. As simple as that. Because it is what? Less than 7. Then the solution will be what? Acidic. The solution will be what? Acidic. If the solution has a pH of what? 7.41, you have to determine the what? The hydrogen plus concentration. In this particular case, just have to take the antilog. Just take the antilog to take it from minus 7. I hope you know how to take the antilog. Just say shifts log, then open your bracket and put your minus 7.41, close it. 3.8. This will give you 3.9 times 6 minus 8 molar. Just press your antilog, you get your answer. Shift log, then open brackets and put minus 7.41. Close your brackets, you get your answer. Now, if a solution has a pH, you are given the pH, we have to calculate the pH. Now, what you need to do for us to calculate the pH, look at it. pH plus pH equals to 14. In this particular case, now we can get our pOH by saying what? 14 minus pH. Now, after getting your pH equals to what? Minus log. That is hydrogen ion concentration. Then taking the antilog, when you take the antilog, you have it as 3.2 times 10 to the minus 9. How will you take the antilog? Second function log, then open bracket, minus 8.50, close your bracket. That's your answer. Now this one is to calculate the pH of still the same thing. In this particular case, the strong acid ionized completely in water. What is the implication here? Implication here is 1 molar of ACl will give you 1 molar of what? Hydrogen ion concentration. What is it? If 1 molar is 0.001, automatically 1 molar here will be what? The same thing as what? 0.001 molar. In this particular case, bringing it down here, just recall that pH equals to minus log H plus. We know that pH is equal to what? Minus log H plus. Then insert this your value into this. If you insert into this, this is what you are going to put in standard form. Move from right to left. 1, 2, 3. That will be 1 times 10 to the power minus 3. Then I've told you, just take this one to the front. You can just do it this way. Take this one, pick the first one to this one first. That will give you what? 3. Then say minus log 1. If you do that, what are you going to get? You are going to get 3 minus 0. 3 minus 0, and that will give you what? 3. Yes, that will give you what? 3. Okay, for the base, the same thing as well. Determine the what? The pH. We are to determine the pH while we are giving what? Sodium hydroxide. In this particular case, I have to get what? Hydroxide ion out. I've gotten the hydroxide ion out. I have to recall this particular formula. It says what? Hydrogen plus equals to what? KW, that is the dissociation constant of water, which is 10 to the minus what? 14 over what? OH minus. This is standard value. Over here you have it as 0.1. By the time you do that one, you have your water hydrogen ion concentration in the solution. Then you start it. pH equals to minus log hydrogen plus. When you do that one, your pH becomes 13. That'll be your answer. Now this is just the same thing, just like increments. Yeah, 1 molar of this is equivalent to what? 2 molar of this. Automatically, if 1 molar is what? 0.02. If 1 molar is equal to 0.02 molar, then what happens? 2 molar will equal to what? Just multiply by 2. That will be 0.02 times 2. Because if 1 equals to this, then 2 equals to what? This times what? 2. And when you do that, what will you get? When you do that, what will you get? You have 0.02 times 2, 0.04. Then what do you have here? You have it as 0.04 molar. In that case, what happens? Then you remember your formula. That's it. When you remember your formula, the pH equals to what? The pH is equals to minus log OH minus. And that will give me what? Minus log 0.0. If I do this, what happens? Minus log like this 1, 2 times 4 times 10 to the power minus 2. And that will give me what? 2 minus log 4. Now to take this one by one. If you first take this one, will give you what? 2. Then take this one. When you do this, what are you going to get? 1.40. Then we remember that our pH plus pOH equals to what? 14. Automatically, our pH will equal to what? 14 minus 1.40. And that will give you what? 12.60. Therefore, this is the basic concept you need to first know. The ionization equation. Once you understand the ionization equation, then it should be very, very easy to manipulate yourself using the formula. Now, when you now have a weak acid, this is another ballgame entirely. When you have a weak acid, for a weak acid, it will not ionize completely in water. Automatically, you cannot just determine the hydrogen plus by from the ionization equation. For that, we have to determine our Ka, that is the acid dissociation constant. And for acid dissociation constant, know that it will be the concentration of the product over the concentration of the reactant. The concentration of the product, you pick them one by one, concentration of hydrogen plus concentration of this over the concentration of the reactant. And in this case, we are given the acid dissociation constant. Then one molecule of this dissociates to form which we know to form this and this. Thus, hydrogen plus is equal to, meaning the concentration of hydrogen plus will equal to concentration of this. In this particular case, we can say after the equilibrium, what happened? This one will have become S. This one will have become S. Why this one will have become 0.1 minus X. This one will have become 0.1 minus X. This one will have been after the equilibrium. It means X will have been taken away from 0.1, and this is what we have here. In this particular case, what happened? This value can be neglected. Instead of having it as 0.0 is 0.10 minus S. Yes, you can let the S go. Why? Because the value of S was negligible relative to this. It's very, very small in that regard. Once it is very, very small, then this total concentration can be approximately equals to 0.10. And when you do that, what happens? You have to determine your S. Ka equals to S times X over 0.1. And we've given the constant, the acid dissociation constant for that particular substance, which is this. When you do that, we will calculate the concentration of AX now. We've gotten the concentration of hydrogen ion in this particular solution. Why are we doing all this? Because this particular compound is a weak acid, and when ionized, it ionizes partially in water. After you've determined the hydrogen plus in the solution, then we can now determine the pH. We also determine the pH, just say pH equals minus log H plus over this. And when you do this, I've told you, when you take this to this, what will you get? You get 3. Then minus, take this to this. That will give us 2.87. Now, what is a buffer solution? Now, we quickly need to talk about buffer solution. It is often necessary to maintain a pH, a certain pH of the solution in the laboratory and industrial processes. These are achieved with the help of buffer solution. Buffer solution or buffer system, or simply buffers. A buffer solution is one which maintains its pH fairly constant even upon addition of small amount of acid or base. Let's say it's a solution that resists pH even when adding small amount of acid or base to the solution. In other words, buffer solution resists a change in its pH. That is, we can add a small amount of acid or a base to a buffer solution, and the pH will change very little. Two common types of buffer solution are, we have weak acid together with together with a sort of the same acid with strong base. A weak acid together with a sort of the same acid with weak base. These are called acid. They are called acid buffer. Look at this. This is a weak acid. This is This is sort of the weak acid, because this hydrogen ion has been replaced with sodium to make a salt. Then you cannot add a strong base to it. Because then we have what we call a weak base. It's salt with a strong acid. Automatically here, is called a basic what? Buffer. This a weak base. Then we form a salt by replacing the what? The by replacing its what? OH. Now we will have formed it here by replacing a weak base, they replace salt with a strong acid. Now for us to form a strong acid of this, what has happened here? We have NH4. The OH has been replaced with what? Chlorine. And the OH has been replaced with what? Chlorine here. Now this is a strong acid, this is base, then you can have, this is a strong base with a salt of that particular what? Weak base. Then you now add what? A strong acid to it. Let me take it again. A weak base and its salts with a strong acid. These are called a basic buffer. Example is ammonium hydroxide. This is a weak base. Then its salt is ammonium chloride, meaning the OH has been replaced with Cl. Then you now add a little strong acid to it without resisting or without changing the pH of the solution. Now let's talk about the calculation of the buffer solution. The pH of an acid buffer can be calculated from the dissociation constant of what? Ka of the weak acid and the concentration of the acid and the salt used. Dissociation expression of the weak acid may be represented, which we know is represented by this. What happened here? The Ka, which is the acid dissociation constant, equals concentration of the product over that of the reactant. By the time you make the concentration of hydrogen plus the subject of the formula, you are going to have what? Ka times what? This concentration divided by this. Okay, good. Yeah, then this formula becomes very, very important. Then the hydrogen plus equals to Ka multiplied by the concentration of the acid, weak acid, over its salt, or concentration of the salt, where is the initial concentration of the added acid and salt, and the concentration of salt, that of the salt used. Taking negative, by the time you do all this, what we needed to just note here is this. You need to know that pKa is equal to what? Log Ka, because we need this particular pKa when you are determining what? The pH of this particular buffer solution. Therefore, pH equals to pKa, and the relationship between pKa and Ka is pKa equals to log Ka. Then from there you have log the salt over the concentration of the salt over the concentration of the weak acid. And this particular equation is what we call Adamson. Adamson what? Assemblage was equation, or simply called what? Adamson what? Equation. Likewise for POH equals to pKb, that is what? Base dissociation constant, multiplied by log of the salt, concentration of the salt over that of the what? Base. We see salt will come up before the what? Base or acid. Therefore, in this particular question, let's quickly look at it. Find the pH of the buffer solution containing 0.20 mole per liter of water. This is the salt. While there is the what? Acid. You remember salt over the what? Acid. Then Ka for acetic. We are given Ka, but you need to understand that we need pKa. And pKa, yeah, we need to know that pKa is equal to what? Minus log what? Ka. That is the relationship. If that is the case, then pKa equals what? Minus log Ka. Do that, you get your what? pKa out. 5 minus, and this one is just, how did they get it? This is 5, because you use this one to multiply this particular one. Then when you do that, you have 5 minus log and 1.8. Then when you do that, what we get? You're going to get this. You can now say pH equals to pKa plus log of the salt over what? For what? And then say what? Simple what? Equation. In this particular case, the salt is given as 0.20 over the what? Acid 0.1. By the time you do this, you have your what? Your pH of what? This out together. And in this particular case, it's just a log 4 minus log 3. This log 4, this log 3. And that will give you this particular answer. Okay, likewise, you can use it to determine the pH when you are given what? This is the salt, why this is what? Okay, why this is what? Acid. But here, straight away, you are given what? pKa. Therefore, you don't need to use minus log. Just substitute it directly and you get your answer out. See, all you need to do just to remember this particular formula. And this is applicable when you are dealing with buffer solution. Now for the base, it's the same thing. Okay, you are given Kb. In this particular, you are given what? The dissociation constants of the base, which is what? Kb. Then I need pKb. For keep Kb, become minus log Kb. Do this. You've gotten it, then you recall. This is your formula. And there's a formula which we have the salt itself 0.025 over that of the base. Then you get your answer. You have gotten your what? pH. Then you know that pH plus pH equals what? 14. Automatically your pH equals 14 minus this, and you get your what? Answer. And